Hey everyone, welcome back. It's Zook here, and today exercise will be number of islands from LeetCode. And this one is quite interesting. It's not too hard, but not that easy. So it's marked as medium, so that's good. But it's nice. It's quite nice exercise we'll be doing. So let's explain what is needed and what will be our solution. So what we are getting here is a grid that marks as a map of, let's say, a flat world. And it gets ones and zeros as indicators in the map. One is meaning of a land, and one means there is water in the map. So what we're supposed to return is how many islands we have in the map. Islands, that means there is a land that's surrounded with water, or if it's on the edge of the map, that means let's call it surrounded with water on the edge because it's just on the edge, so let's call it an island as well. This is the exercise, of course. But if you have two adjacent lands, that's not supposed to say that, but go with me with my English. So let's find that will still be one island because they are close together and they are connected. So as you can see in the example here that I copied to make it a bit easier, you can see that we have quite a big island right here. All of this that I just marked is one big island. They are all connected and they are surrounded with water, as you can see right here. Well, diagonals are not relevant, but you can see it's surrounded with water and it's on the edge. So this is one big island. But if I have another land set here on the map, we'll have two different islands because we have the big one that I just marked and we have this one that is surrounded by water and it's on the edge. If I have another one right here, I have three different islands because this one is surrounded by water as well. And for diagonal lands, this will not be one big island, it will be three different islands. Let's ignore the big one here. So we have one island, second island, and third island. So on diagonals lands, it's still marked as different islands. But if we have it right here, another land, so this will be another single island altogether. So on the map we have two different islands and not four. And how we are going to solve that and what will be the time complexity and the memory complexity we're going to use. So time complexity, what I'm referring to do is just going for iterating through all the elements one by one. And that will be, let's say, O(n) if n is the amount of squares inside our map. So that will be O(n) is our time complexity. And for our memory complexity, I will just be reusing the grid that we are getting because we are getting a grid, an array of arrays. And I'll just update that with things I have visited, with squares I have visited, and I want to ignore. We can create another grid that will resembles the same grid that we are getting as an input, but I don't see a reason to do that now, so we can skip that. But if it's required, not updating the original list that we are getting as an input in the function, we can create another grid that will be marking as the visited items that we just marked. So why I'm in as a visited? Because what I'm planning to do is iterating for each item. And when I'm iterating, let's say this one, I know this is a possibility for an island, but I don't know the size of this island. So all I need to do is go to the next step on his right and go on his bottom, left or top, even though this is on the edge, so I can ignore those. But I need to go right and see if there is more land on the right. And if there is more land, I still need to keep going and to check if there is more land on the right of the original one, because all of those three will be marked as a single island. And I don't want to be counting as 2 islands or 3 islands. But as I'm going for this one and then going down and then going right, and let's say I got to a stop, and on the next loop that I'll be iterating later, I'll be reaching out here again. And if I won't change anything, I'll see 1 here again. And I'll think there is another island, but that's not true, because this island, this land is connected to the original land that I already tested. So this will be a one single island and not 2 islands. So back to our code and what I'm referring to, what I'm going to do. Well, first you can see right here, I'm getting the grid, and I'll just start iterating as I mentioned. First I'll be iterating the grid, getting the rows themselves, and then on each row I'll be iterating to get each column inside the row, and I'll have a row index, call index, and then I could start see what is happening here. So as I'm getting this, I'm first checking, are we in a land square? Is this land, do we have land in this square? If so, first you can see that I'm counting, and the count that we are going to return at the end, because this is the count of islands. And I'm doing explore island, so I'm giving that the grid, the original grid that I got, and the indexes of where I'm at now. So on this first iteration, I'm giving them 0 and 0, and the grid itself, of course. So first what I'm doing is just zeroing out the square, because I know it was a land and I don't want to check that again. So I'll just zero that back to 0. I'll make that 0 because for me, for now, it's only water. So as you can see here, I'll do that. Let's add text here, and I have a count of 1 island. Let's island count. Okay, so I'm here. I zeroed my first square. And then I'm just getting the row length and the column length and the column length, just for some annoying checks. I know there are probably better ways of doing what I'm doing right here, but this was just quick before I was doing the video. What exactly I'm doing, just if I have a square right in this position and it has just on the edges of the map, I want to ignore those two from the top and on the left for this current position, because they are not relevant. So I don't want to check them because I'll get out of bounds exceptions. So if the row is okay, the row will be okay, this will be skipped because the row I'm getting is 0, the call I'm getting is 0, because this is the spot and that's not good for us. But if the call is smaller, the call length, that means the call length right here is 5, and I'm giving that 0. That means I can enter right here. And I'll be checking if that position that I'm checking, let's say the bottom right here, I think this is the bottom. Grid row, yeah, this is no, that's the right. Yeah, my bad, it's the right side. I even wrote it in the comments right here. So just showing what I'm doing. This one will check the above square, this will check this left square, and this will be checked the right square. So for our current case in the first square, we not need to check only the right side and the bottom. So if the right side has land, that means that we need to now explore the land on our right side, on the next square. Because there is land, we need to explore it further away. Because we need to see if this was land and this is land, there is a possibility the island is bigger only from those two that we already checked. So the island can get here, here, and further away. So what we'll do here, we'll just go again and do explore island. We'll give it the original grid and the row that I'm currently at, and I'll just skip to another column because I'm checking on my right side. I was here, and I want to now check this guy. So as I'm pressing that, let's go back to explore island again. And now we have different indexes, 0 and 1. That means I'm right here. As you can see right here, we are zeroing the land again. Zeroing the land. And now we are checking right, bottom. And we'll be checking left as well, but the left is not relevant because this is water, because we already zeroed that. So we'll be checking right again, and what will happen with right, we will go another step further. That means we are calling explore island with 0, 1 plus 1, that's 2, and we are coming back here with the indexes of 0 and 2. 0 and 2, that means we are here, and we'll do the same process, zeroing this and exploring our right, top, left, and bottom. Left is not relevant, top is not relevant, it's out of bounds. This is 0 as well, because I didn't paint it at first, because this is the default map, but this will be 0 as well. Everywhere it's not a 1, it will be a 0. But I won't start typing all of that because it's hard. But as I'm here, I'll look again to the right side. I'll see there is a 1. I'll do explore island, give it the next index, and I'll give it 0. And then exploring, checking my right side, checking top, left, and bottom. That means I need to explore bottom. When I'm exploring this part, I'll be marking that as 0. And then I'll see there is no more exploration when I got here. So if there is no more exploration, I'm just returning the grid. After everything here was set, just returning the grid. The grid got updated with everything that was needed. And in the end, we get a grid that is cleaned out for the current island that we are checking. Let's just go back right here that we started here as 0, 0. As we were 0 here, we are checking our right side, and then we started the full, let's call it DFS, depth first search. We just started drilling into all the islands that we have found. This would have been found as well as 0. And, well, this one as well. And this one as well, and this one. So in the end, as you can see right here, because we are doing a DFS, we're just scrolling down everything. As you can see here, I'll show the example again. If this was 1, this was 1, this was 1, and this was 1. And we got here, we zeroed out all of those, and we got back here. And that means we finished the right side, and we are now here on the bottom. So as the bottom here, we'll be checking this one, and this one will be zeroing that. And he will be checking on his right side, bottom and left. So bottom again, he will check 0 and start checking this one, 0 and 0. So in the end, we'll get back a grid full of zeros, as there was only one island. But let's do an example of one right here and another one right here. It's pure new different example. So what will happen here, we'll be iterating for all the elements. In this case, we are jumping on this one because this is one island. So we're checking that. And as we get here, we'll start checking if there is something above us. In this case, there is nothing. And if there is something on our left, nothing, and then we'll be checking on our right. That means we're checking on the right side. Do we have land here? No. So we are ignoring that. We don't need to do anything here. We're not entering into the if statement. And same for the bottom. Do we have land on our bottom side? No, that's fine. But before that, I forgot to mention that we are zeroing this square. So what will happen here, we'll be returning after the first iteration of indexes 0 and 0, we'll be getting a new grid, and the new grid will look something like this, full of zeros except of this one. But because we have a count here, we counted the first island that we got. And then we'll continue iterating through all of those elements, all of those squares. And all of those are zeros, so we will ignore that. As you can see right here, only where there is one will be entering into the explore island until we got to this point. And if we got this point as 1, you can see that I'm counting +1. That means I have 2 islands now. And for the grids, we'll be doing explore island again. And I'll just get here and I'll zero that out and be checking again left, top, right, and bottom. All of those are water, 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 and the edge of the map. So everything is ignored and nothing is updated. And in the end, I'm just returning the grid, and that's all. So in the end, I finished all my loop right here, and I'm returning the count. This is currently 2. in the case of this one. But if you have another element right here, that means if I got here, I will be exploring my left is water, top is water, right is a land, so I'll be doing explore island, and I'll be zeroing that as well. So we have two different islands, even in this case. And after all of that, I just need to show that everything is working. I can do one code again. And this is fine, and let's do a big submission to see that everything got passed. And everything seems to be good. Hope I explained it right. I think I talked a lot, but maybe it will help someone. Thanks guys, have a good one.